Hello guys, this is the 11th lecture in JEE Concepts, which is Questions on Newton's Laws, 4th. In this lecture, we are going to discuss about different types of questions asked in case of tension and strings. Now, just after going through this and the previous video, you will never gonna face any problem regarding any kind of questions related to tension and strings. So just go through this video and the previous video 2-3 times and practice as many questions as you can. And believe me, you will feel very comfortable in doing questions on tension on strings after going through these 2 lectures. No matter how difficult the questions will be, just try. Just mark my words and just try. So now let us move towards this lecture. Well, this is actually what I have told, types of questions on tension and strings. And this is the first type in this regard. And what type is it basically? In these types of questions, motion of all blocks are not directly dependent on each other. Like over here. This is the first block M1 and this is the second block M2 and third block M3. Now when this M1 block moves, say upwards with an acceleration A1, then obviously this pulley, say this is pulley B and this is pulley A, then pulley B will also move with an acceleration of A1 but in the downward direction with respect to this pulley A. And since this pulley A is at rest with respect to ground, so this acceleration A1 are also with respect to ground of mass M1 and pulley B. But when this block of mass M1 moves, then obviously this B moves downward. But this movement of mass M1 is not affecting the direct movement of mass M2 and M3. What I mean is, so just by looking at the movement of mass M1, we cannot say that this M2 is gonna move upward or downward, or this M3 is gonna move upward or downward, because the movement of M2 and M3 are independent of this movement of mass M1. But when this mass M1 moves upward with an acceleration of A1, then this M2 and M3 as a whole, means this thing as a whole moves downward, because this is moving upward and this pulley B is moving downward. So these two masses as a whole will move downward with an acceleration A1. But the movement of M2 and M3 with respect to the pulley B, we cannot depict. M2 either can move upward or downward, M3 either can move upward or downward. That we cannot depict. We need to assume at first and then we have to move accordingly. So this is basically the same type of questions which I have discussed in the previous video, question number 1. So go through the question number 1 of the previous video, and that was even more interesting question than this question. This question is actually from H.C. Verma, but the question number 1 of previous video was not from H.C. Verma. That was a more complicated question with respect to this question. So just also go through that question. Now let me solve this question over here, the type 1 question. So the question is like, let M1 is equals to 1 kg. This is given as 1 kg. M2 is 2 kg, M3 is 3 kg in figure. Okay. Find the accelerations of M1, M2, M3 that we need to find. The string from the upper pulley to M1, like upper pulley to this M1, this string is 20 centimeter. Okay. Or we can say 0.2 meters. Since this system is released from rest, so U is equal to 0. Initial velocity of block M1 is 0, as I have told many times. Now, how long will it take before M1 strikes the pulley? That is the first question. We need to find the time before the M1 strikes the pulley. Now, when M1 is going to strike the pulley, when this M1 is going to move in this direction, that is the acceleration of M1 is in the upward direction, then only it is going to strike the pulley. And the second part of this question is like, suppose M2 is equals to 2 kg, which is already there, and M3 is equals to 3 kg, then what should be the mass M1 so that it remains at rest? Initially it is at rest, it will remain at rest. That is the second part of the question. So let us solve the first part of the question first. For that, again, let me assume that the positive y-axis is this. Like we are taking upper side as the positive y-axis. And I'm assuming the acceleration of mass M1 as A1 in the upper direction with respect to ground, or we say with respect to pulley A, because pulley A is at rest with respect to ground. So no difference. Then this pulley B is going to move down with an acceleration A1. Since M3 is having more mass, like 3 kg, and M2 is having lesser mass, that is 2 kg. So I'm letting that this acceleration over here is A2, and so M2 will move upward with A2. But these A2s are with respect to this pulley B. Okay, so we need to find the acceleration of M2 and M3 with respect to ground. So here acceleration of M1 is equal to plus of A1. I'm writing all these accelerations now with respect to ground. Then acceleration of M2 will be equal to plus of A2 minus of A1, because A1 is this negative, and acceleration of M3 will be equal to minus of A1 minus of A2. So these are what? These are with respect to ground. These accelerations are basically with respect to ground. Okay, the question is also here that find the accelerations of m1, m2 and m3. So this is also the question. We need to find the acceleration of m1, m2 and m3. Now let me locate the forces on each of these masses. So for m1, it will be like m1g over here and tension 2t over here. Why I'm taking this 2t, I'll let you know. This is also 2t because this will be t and t. So I'm keeping the calculations easier. That's why I've taken this t and this is 2t, because when you write the force balance for this pulley B, then it will be like this t and this t, and that will be equal to this 2t. So t plus t is equal to 2t. That's why here this t and t. I've already discussed this in the previous video. Just go through that. After that, this mass m3 will be what? m3g, and this will be m2g, and this will be t, and this will be t. Now let me write these equations in the next page. Then for mass m1, if it is moving in the upward direction, then that will be what? 2t minus of m1g is equal to m1 into a1. Why? Because I have considered the acceleration of m1 as a1 in the upward direction. That's why 2t minus of m1g is equals to m1a. Now for mass m2, it is moving upward with acceleration a2. So for mass m2, it will be like t minus of m2g is equal to m2 a2. And for m3, it will be m3g minus of t is equal to m3 a2. So these are the three equations that we are having now. Actually, I am following the same steps that I have discussed in the previous videos. First, take the system and axis. Then second, locate the forces. Third, free body diagram. And fourth, write the equations. So these steps I am not missing. If you see it clearly, I am actually following those steps only. Now let me write with the values of masses. Then for m1, it will be 2t minus of g, because m1 is 1 kg, a1. That is for m1. Okay. For m2, it will be t minus of 2g is equal to 2a2. That is for m2. And for m3, it will be 3g minus of t is equals to 3a2. That is for m3. Now if you look clearly over here, then the variables are tension T, acceleration a1 and a2. Rest all other things are known. Only g is there, that is known, acceleration due to gravity. So we are having three unknowns and three equations. So you can easily solve this by applying some mathematics, and after solving you will get acceleration a1 of mass m1 as 19g upon 29 in the upward direction, that is positive. Acceleration a2 as 17g upon 29 in the downward direction, that is negative. And acceleration a3 as 21g upon 29 in the downward direction, again negative. So that was regarding the acceleration of mass m1, m2 and m3. The second part of the question was, we need to find the time when the block of mass m1 gonna hit the pulley A, and it was given that initially the block of mass m1 was at rest. So u was 0, and the acceleration of mass m1 now we already know, that is in the upward direction as 19g upon 29, and x was given as 0.2 meters, like 20 centimeters. So from here, if you apply Newton's second equation of motion, then x is equals to ut plus of half at square. Now this u is 0, so this term will be 0. X is given as 0.2 meters, half multiplied by 19g upon 29 multiplied by t square. If you solve for t from this equation, then you will get it to be 0.25 second, and that is the answer. Now the third part of this question is, like suppose m2 is 2 kg and m2 is 3 kg, which is already the case here. What should be the mass m1? Like for this question, we don't know mass m1, which was 1 kg for the previous two questions, so that it remains at rest. Okay, mass m1's acceleration will be 0. So for that, let me write the forces. Now here in that case, this a1 is basically 0. So the forces on m1 will be, this will be m1g, and this will be 2t. Here it will be 2t, here it will be t and t. And this again pulley B is having 0 acceleration. Okay, and this will be m3g, this will be m2g, and suppose the acceleration again as a2 and this a2. So writing the equations again, for m1 it will be m1g is equal to 2t because acceleration is 0 in this case. For m2 it will be t minus of m2g is equal to m2a2. For m3 it will be m3g minus of t is equal to m3a2. So again writing the masses for m2 and m3 because we don't know the mass of m1. T minus of 2g is equal to 2a2 for m2 and 3g minus of t is equal to 3a2 for m3. So here from these two equations we are having two unknowns, that is t and a2. Two unknowns, two equation, we can easily find the tension and the acceleration, that is a2. But we don't need to find a2 here, we just need to find the tension because that's only what we need over here, this t, to find this m1 because g we will already know. So if you just find t from these two equations and put that t in this equation, then you are going to find m1 as 4.8 kg, and that is going to be the answer. So this is it for question number 1, guys. I have actually taken these 3 different questions in HC Verma. Actually these are the 2 different questions, like question number 1 and 2 in one question and part 3 in the another question, but I have taken all the 3 parts in the same question. So this is actually similar question to the question number 1 of the previous videos. So just practice these 2 questions to have a good hold on first type of questions on tension on strings, that is motion of all blocks are not directly dependent on each other. Now let us move towards the second type of question. So this is the second type in which motion of all blocks are directly dependent on each other. So what this basically means? Well, for more clarification, I have taken a lot of different kinds of cases, like 1, 2, 3, total of 7 cases. And also in the previous video, the second and the fourth question was totally on this second type of situation in case of tension on strings. So just go through the question number 2 and 4 of the previous video also in order to find this type of question on tension on strings. So what this basically means? Well, in the previous question, as I have discussed, that motion of all blocks are not directly dependent on each other, and I have also told you the meaning of that when mass m1 was moving, then the acceleration of mass m2 and m3 was not completely dependent on the acceleration of mass m1. It was relatively dependent, that is indirectly dependent but not directly dependent. Here in these cases, if you see, suppose for case 1, if this mass of 1 kg moves downward like this, then the motion of this 1 kg is directly dependent on this acceleration of block of mass 1 kg, that is this mass. If this moves down, then this moves this side with the same acceleration in this case because it is connected with the same string having the same tension. Like if T is tension in this string, then this also T, and in this also T. Actually, for these second type of questions, you can apply the constraint equations that we have studied in the previous video of question number 2. So this second type are also governed by the constraint equation. In all these cases, you can apply the constraint equations to find the relationship between acceleration of two masses, like this mass and this mass. No, not in the case number 3. Actually, this is a slight different case with respect to all these 6 cases. So I will discuss about this in a separate slide. Like this mass and this mass, this mass and this mass, this mass and this mass, or this mass and this mass. You can find the relationship between the acceleration. For case number 3, actually, the acceleration for all these 3 masses will be same because these strings are always in tension and the length of the string is constant. So the acceleration for these 3 masses are always same, but the tensions are going to be different because in between we are having a mass, and I've already discussed this, that if there is a mass in between the strings, then tensions are going to be different on the 2 sides of the strings. So here if it is T1, then here it will be T2. For this I'm going to discuss it separately, so don't worry for now. For all different cases, the motions are directly dependent on each other. Say suppose here also I'm taking acceleration of this is A, then acceleration of this 2m mass is directly dependent on the acceleration of this mass, because when somebody just pull this string in this direction, then some part of this string from here is gonna go in this direction, and just because of that this 2m mass is gonna move in this direction. Like the motions are dependent. if you're gonna move mass m, then the motion of mass 2m is completely dependent upon the motion of this mass m. Similarly here, the motion of mass 2m is completely dependent on the motion of mass m. If mass m is moving in this direction, then this string is gonna move upward, then this string is also gonna move downward like this, and this pulley is gonna move somewhat upward, and just because of that, this 2m is gonna move upward. So the motion is completely dependent. Here also, just see for yourself. If I am just pulling this block A down with an acceleration A, then this string is gonna move down, this string gonna move up, and this again down, so this will move up, and hence this block B will move up. So they are completely dependent, but you need to find the acceleration. It is not like that if block of mass A is moving down with acceleration A, then this block of mass 5 kg is moving up with acceleration A. No, this is not the case. You need to find the relationship between acceleration, and this also I have discussed in the previous video of question number 2 and 4. That is how to find the relationship between the accelerations in these cases, like question of second type. You will not be able to find the relationship between the acceleration for the first type of questions, and that's why I have taken A1 and A2 separately, and then we need that much equations to solve A1 and A2. But for these types of questions, you can actually find the relationship between the blocks of different masses, and I have also discussed the shortcut way of doing that. The first way is the long method is constraint equations. You need to write the constraint equations by taking the length of the strings, as I have discussed in the previous video of question number 2. But I have also discussed in the same video, in the same question, this shortcut method. So I'm going to use the shortcut method over here to find the relationship between the accelerations of two masses. Here also 5 kg and 2 kg. If you're going to move this 2 kg, then it will directly affect the motion of this 5 kg. But how? What will be the acceleration? If I'm saying that by acceleration A it is moving in this direction, so by what acceleration it will move in the downward direction? That is the question, and that is again I'm going to discuss. I've already discussed in the previous video. So for that, actually you need to find the tensions in the string. You need to assume the tension for one string, and then for the other string you need to find the tension and then proceed in a manner I will just depict in this video. So say for first case, if I am letting this as tension T, then here also it will be tension T. It is the same string. So if this is gonna move with an acceleration A downward, then this is gonna move with acceleration A in this direction. This is the simplest case in all these 7 cases, because here only one string is involved. In the second case, if I am letting this as tension T, then here it will be T, and here it will be T, and here it will be 2T. Okay. So for this case, what will be the acceleration of this 2m mass if I am letting that this acceleration of m as A1? Well, let this acceleration as A1 and this as A2. Then we're going to find the relationship between these two. So for finding the relationship, you need to just write that for 2t we are having A2 acceleration, and for t we are having A1 acceleration. This t with A1, this 2t with A2. You just need to map. This is the shortcut actually. Then where 2 is involved, like 2 multiplied by 2, you just need to have that 2 over here with A2, like this. 2A2 plus of A1 is equal to 0. That is the relationship between A1 and A2. And if you already know the direction, like if A1 is moving in downward direction, then A2 will move in the forward direction like this. If you already know the direction, then no need to confuse between this plus sign or minus sign. You can just take A1 is equal to 2A2 like this, because we already know the direction. So if you know the direction, then no need to confuse between this plus or minus sign. Otherwise, just proceed with this plus by taking this A1 and minus A2 like that, and then in the end you will get the exact answer, either plus or minus, which you have assumed initially the direction. Okay, for this third case, I will discuss it in the separate slide. For this fourth case, if I am letting this T, then here it will be 2T. Always try to take like this. Don't go into complexity of taking this as T, then this will be T upon 2, T upon 2. It will complicate your calculations. So just stick with this 2t and t concept only, or 3t, 4t like this. Like for 2t, I am assuming this acceleration is A1 and this is A2. So if it will move like this, then this will move like this. So for 2t it is A1, for t it is A2. So again 2A1 is equal to A2 for this case. For this case, again this is t, this is t, this is t. So this is what? 2t. For 2t, I am letting this as A1, and for t, I am letting this as A2. So that is again 2A1 plus of A2 is equal to 0. or just 2a1 is equal to a2. Again for this, I'm assuming this is t, here also t, then this will be 2t, and I'm letting this is a1 and this is a2, then same 2a1 is equals to a2. And similarly for this, t and 2t. Similarly for this is a1 and this is a2, so again 2a1 is equal to a2, same. Okay, now the other kind of questions that may be asked is like you need to find the clamp force on this pulley. So for finding the clamp force, you already know that there are tensions involved. If you write the free body diagram for this pulley, then there will be this T and this T. So two forces are there, like this T and this T in the perpendicular directions. So you just need to have under root of T square plus of T square, that is root under 2T. That is the clamping force on this pulley. So this is another kind of question that may be asked. And in this question, it is already asked in the HC Verma questions. That's why I'm telling this over here. Now let me take two questions separately from these all cases. I've already told that I'm going to take this case 3. So other than that, let us take this case 4 at first, just to make you understand how to actually solve the question. So here, let us take this is tension T, this tension T, and this is 2T. This will be 2mg, and this will be in this direction, mg sine 30 degree. Why? Because in this direction it will be mg, and this will be theta. So this will be mg cos theta, and this will be mg sine theta, and here it is normal. So in this direction n is equal to mg cos theta or cos 30 degrees, and in this direction it will be mg sine 30 degrees and t. So I am letting the acceleration of this mass as a1 in the downward direction, just suppose. Then in this direction, this will have some acceleration, say a2 of this mass m, and the relationship will be equal to, for 2t it is a1, for t it is a2. So 2a1 is equal to a2 because we already know the direction. Now just writing the equation, like for this mass 2m, then 2mg minus of 2t is equal to 2m a1, and for this mass m, t minus of mg by 2, because sine 30 degrees is 2, that is equals to m into a2. These two are the equations that we are having now. Now multiplying 2 throughout the equation, this we will get 2t minus of mg is equal to 2m a2. So let me take this as equation 1 and this as equation 2. Okay, so we are having two equations now. Just add these two to get mg is equal to 2m a1 plus of a2, and we already know that 2a1 is equals to a2 or a2 is equals to 2a1, that we already know. So just put that here, m and m cancelled out. So g upon 2 is equal to a1 plus of a2 is 2a1, that is 3a1. So from here a1 is equals to g upon 6. Okay, g upon 6, that is plus g upon 6. And what we have assumed? We have assumed that a1 is moving in the downward direction. So yeah, it is okay. a1 is actually moving in the downward direction with an acceleration of g upon 6. For this mass m, a2 will be what? a2 will be 2a1, that is 2g upon 6 or g upon 3. So a2 or this mass m is going to move in this direction with an acceleration of g upon 3. So that is the answer. So this is the manner in which you need to proceed for these kind of questions. Now just try all different cases of this step 2. And regarding the question number 3 or case number 3, let us discuss. This is a somewhat different case in which there are two strings, not a single string, and in between the two strings there is a mass, so the tensions are going to be different. Here let this is tension T1, then it will be here as tension T2, but acceleration is going to be the same. Why? The string is going to be tied throughout the motion of these 3 blocks, so the acceleration is going to be the same for these 3 blocks, but the tensions are going to be different. So let me proceed. Like here it will be 500 grams multiplied by acceleration due to gravity, and it is T1. Let us take acceleration of this is a, and this will be also a, and this will be also a, same acceleration. Here it will be 50 multiplied by g, and T2. Here this will be T1, this will be T2, and in this direction mass, that is 100 m into g into sine theta, that is sine 30 degrees. So 3 forces are there, this mg sine 30, this T1, this is actually T2, and this is T1. Now writing for this, at first it will be 500 multiplied by g minus of T1 is equals to 500 a. That is the first. For this second one, it will be like T1 minus of T2 minus of 100 g by 2, because sine 30 is 2, that is equals to 100 a. And for this, that is the third mass, it will be like T2 minus of 50 multiplied by g is equal to 50 a. So we are having these 3 equations. Now when you add these 3 equations, then this T2 will be cancelled out, this T1 will be cancelled out. So we will be left with 500 g minus of 100 g by 2 minus of 50 g, that will be equal to 50 plus 100, 600, plus this is 50 actually, not 5, plus 50, that is 650. So 650 a. Upon solving, this is actually 50. So 500 minus of 50 minus of 50, that is 400 g upon 650 is equal to a. So that will be 8 upon 13 g, and that is the answer. So this is the manner in which you proceed for these kind of questions, like case 3, in which the tensions are going to be different because there is a mass in between the 2 strings. So now let us proceed further. Now this is the third type of question in this regard, in which there is some movement along the rope, like either a monkey in this question, like the monkey is moving along the rope, or some block is said to be moving along the rope, like that. So this is a kind of questions in which there is some sort of movement along the rope. So let me solve this question for better understanding. Like here the monkey B, this is monkey B, in figure is holding on to the tail of monkey A, this, which is climbing up the rope. This monkey A is basically climbing up the rope. The masses of the monkeys A and B are 5 kg and 2 kg respectively. If A can tolerate a tension of 30 Newton in its tail, this A can tolerate basically a tension of like T max is 30 Newton that he can tolerate. What force should it apply on the rope in order to carry the monkey B with it? So here 2 cases are there basically, that is the maximum force and the minimum force. Why? Because in the maximum force, I will consider the acceleration of monkey A. That is, monkey A is gonna accelerate with some acceleration, while in case of minimum force, the acceleration of monkey A will be 0. That is, the monkey A is not going to accelerate. So the answer is going to be in a range, F max and F mean. There is going to be a range of answers for this question, and this T max is given to be 30 Newton. So let me proceed. Well, again you need to consider the systems at first. So I am taking the first case as F max. So first let me consider A as the system. Then the T max is basically 30 Newton. So it will be something like this, 30 Newton, and the mass of A is 5 kg. So 5g. Then tension T over here, and acceleration I am supposing is A, upward. So from here, T minus of 30 minus of 50, because G is 10, that is equal to M into A, mass is 5, so 5 into A. So that is T minus of 80 is equals to 5A. That is equation number 1. For this monkey B, this will be the mass, that is 2G, and the tension will be in the upward direction 30, and acceleration in the upward direction as A. So that will be 30 minus of 20 is equal to mass is what? 2A. So that is 10 upon 2, that is A. So A is 5 meters per second square for this monkey B. So now we know the A, just put that A over here to get, so A is 5, T is equals to 80 plus of 5 multiplied by 5, that is equals to 105 Newton. So that is maximum force. So F max is what? 105 Newton. For the second case, like F min case, I am assuming the acceleration is 0. And for 0 acceleration, as you can see from here, like this, if A is 0, then T will be what? 80 Newton. So that is F min. So the range of force will basically vary from greater than 80 to lesser than 105. You can say equal to. So that is the answer for this question. Like from 80 Newton to 105 Newton, the force is going to vary that this monkey A is going to apply on this rope. So this is the manner by which you need to proceed for third type of question when there is a movement along the rope. Now let us move towards the last type of question, which is basically miscellaneous. Why miscellaneous? Because a lot of different questions may be involved in this fourth type of question, and the example of which is the fourth question in the previous video also, in which there was a force which is varying with time. So a different question was involved, which made the question even more complicated. So for these kind of questions, you need to relate different questions along with the concepts of tension on strings. So now just see for this question and also see the fourth question of the previous video for more clarity. So for now, let me do this question. Like figure shows a man of mass 60 kg. This man is having mass of 60 kg standing on a light weighing machine kept in a box of mass 30 kg. This box is having a mass of 30 kg and this is basically the weighing machine. Okay, now the box is hanging from a pulley fixed to the ceiling through a light rope. This, let me take the tension as T, like this, the other end of which is held by the man himself, this over here. If the man manages to keep the box at rest, what is the weight shown by the machine? Okay, if the man manages to keep the box at rest, this whole system is not moving at all. In the first case, acceleration is 0. For that, let me again assume the system. Like for this man, if I'm letting as the system, then the forces will be like its mass 60 kg, weight, then the normal N over here, normal reaction. After that, this tension. Okay, so the equation will be, and the whole system is at rest. So T plus of N is equal to 60 G. And when I'm going to take this box as the system, then it will be like this normal reaction. Weight of the box is 30 G and tension is T, like this. T is equal to N plus of 30 G. We are having two equations. Let me take this as first, this is second, like this. Now put the value of T over here from the second equation. Then N plus of 30 G plus of N is equal to 60 G. That is what? 2N is equal to 30 G or N is equal to 15 G. So that is what? 15 G upon G, that is 15 kg mass, will be shown by the weighing balance. In the first case, when the whole system is at rest, that is the 15 kg for the first part of the question. The answer is 15 kg when the whole system is at rest. Now the second part is, what force should he exert on the rope to get his correct weight on the machine? Now he wants the machine to show the weight as 60 kg itself. So what is the meaning of this? The meaning of this is that he wants the normal reaction to be 60 G. Then only 60 G upon G, that is 60 kg, will be shown by the weighing machine. Okay, so he wants the normal reaction to be 60 G in the second part of the question. But for having this much normal reaction, actually now the system is not going to be at rest. The system is moving now, because the system will be at rest only for the case when normal reaction is 15 G. That is, the mass shown on the weighing balance will be 15 kg. But for this case, the system is not going to be at rest. So in this case, suppose the system is having an acceleration A in the upward direction. This man is also going to move in the upward direction with an acceleration A, and this box is also going to move with an acceleration A in the upward direction. So accordingly, the first equation will be like this. T plus of N, like it will be A over here, and this will be A like this. T plus of N minus of 60 G is equal to what? 60 A. That will be 1. And for this, T minus of N minus of 30 G is equals to 30 A. That will be 2. So now the equations will be like this. Now we already know N is equals to 60 G, because that man wants to show his correct weight on the weighing machine. That's why N is 60 G. Now putting that, T plus of 60 G minus of 60 G is equals to 60 A basically. This cancelled out. T is equals to 60 A from the first. Then from the second, we like T minus of 60 G minus of 30 G is equals to 30 A. That is T minus of 90 G is equals to 30 A. Putting this value of T in this equation, it will be like 60 A minus of 90 G is equals to 30 A, or 30A is equals to 90G. Because 3 times 3 is 9. So A is equals to 3G. That will be the acceleration. And the tension, that's what we need to find. The tension will be what? That will be 60A, or 60 multiplied by 3G, that is equals to 180G. Approximately what? 1800 Newton. That much force he needs to exert on the rope in order to get his correct weight on the weighing machine. So this is it for this video, guys. Just practice a lot more questions from tension on strings and just contact with me in case you're having any doubt, or in case your situation is different than the situations I've discussed in these videos of tension on strings. Not only in this video, but on the previous videos also. You can also comment me in the comment section, or you can contact me on Facebook or LinkedIn or even Twitter. So till then, guys, thank you.